Sorry, I'll read it out anyways. So I'll try my best to do that. And I have to apologize for everyone who's going to watch this either via live stream or I'm actually having this recorded for my YouTube channel. You can't see all of the slide, but that's fine. I'm just going to talk over it anyways because there's a lot of stuff I wrote just so you could kind of read it, but then there's also a lot that I really have to explain. Also, this is something that I actually made. I call it the God theory. It's based off of something that I called the God hypothesis. So this is my own theory that I essentially made. And it's not perfect at all. It needs serious refinement. But I made an equation just in the short time that I had. But first, I really want to ask the Lord's blessing on tonight because this is going to take a lot of wisdom. I'm going to need a lot of the Lord's wisdom tonight. And I need to explain advanced terms to levels that even I can understand without setting my brain on fire. There are a lot of deep stuff in this. So, all right, let's pray, okay? Lord, I thank you so much for this opportunity to talk about ultimately your great creation and how it points towards your greatness, God, and how we are without excuse, God. And I just pray that all these people would take these things in, would understand them, would ultimately use these things to fight for your kingdom, to share your gospel, and to make a difference in your name, Lord. And I ask all of these things in Jesus' name. Amen. All right, so I think pretty much all of you know that I evangelize on a consistent basis, and I've talked to my coworkers over and over and over and over and over again about pretty much all apologetics and the weirdest questions you could ever think of, they've asked it, which got me to learn a lot and to train, and it really helped me to get a better perspective of like, how do I present the gospel to them, and even just everything biblical in a more materialistic way, which sounds kind of counterintuitive, but it's from the idea of a box top view. So you go from ground to top, right? So what is observable, and then you come to a conclusion, which is kind of the opposite of what we usually do, right? We believe that God exists, and then we go from there. We reason from there. But pretty much everyone else in the secular world goes from bottom to top. So you have to like reason with them. And so apologetics are essentially, it's like taking that top down and converting it. It's really advanced. And it takes a lot of philosophy and a lot of work. But there are some simple key things that even if you just literally just understand your Bible, you'll actually start to be able to express these truths to people and answer these questions that people have, like say something like, how do you know for sure that God created the universe, or that the universe didn't just create itself, right? Why didn't just something material, why not just say that something material is eternal, right? Why say that God is eternal and that he's the one who created the universe? Why not just say material things are? So that's mostly what I want to focus on. Again, the God theory here that I actually wrote out, this is it just specifically, and I guess I'll just look at it. The physical universe and the metaphysical world and all things that are dependent on, and all things are dependent on and could not exist without an independent divine being who is infinite and holds no physical limitations of his creation, which I guess that would make him infinite. So such as time, space, matter, and energy. So we know that those are what are essentially the makeups of the universe, right? We have material things, we have energy, and we see those the effects of that in physics. We have space, the continuation of time. I mean, space is all around us, for goodness sakes. I'm just waving at space here, okay? But all of those things are what pretty much the universe is, and the creator for those things cannot be those things. So it has to be greater than those things. It's kind of the principle of cause and effect. It's just a rule from a philosopher, a principle, that the cause has to be greater than the effect itself, right? So if I actually design a phone, I actually take lots of time and thought into this. This thing cannot be greater than me. I could never make this thing greater than me. Not in the sense of physical limitations, of course, because I'm myself unlimited. But of the ability that I have, this thing could not be greater, right? So I have the ability to create a thousand phones or even like robots, but those robots could never meet the level of complexity that I am. Maybe could be close or near or even very close to the same, but could never be greater. So in that sense, the creation cannot be greater than the creator, right? And we know that this is a biblical principle, right? And that we are essentially all finite beings, whereas God is infinite. And he did that, of course, for our own good, and ultimately then we worship him because of that. He is worthy of worship. But I have an equation. Don't look at this for reference, please. It's terrible, but everyone knows the first verse in the Bible, right? In the beginning, God created the heavens and the earth. So I actually got this from Kent Hovind. He did this years ago. He pointed this out. Beginning, you have time, right? You have essentially time at the very start of time. And then you have God creating things, the heavens, which would be sky, it would be space, and it would also be, you have earth, which is matter, and then it doesn't necessarily have energy in there, but scientific evidence like Einstein's general theory of relativity points that energy requires a beginning just like matter, space, and time. So you have time, space, and matter all beginning right here in this verse. Everything starts. So the theory is kind of like based off of that, right? So the question then still is, like, why not say that something material essentially just created the universe? But first we have to go to something called surge. I hope I don't give you too much information in too little time that I have. But this is just an acronym that Norman Geisler and Frank Turek came up with in their book, I Don't Have Enough Faith to Be an Atheist. Amazing book, by the way. I suggest that everyone reads it. It's a really good general overview of just all of the just basic evidence for not only God's existence, but also Jesus rising from the dead. But the acronym SURGE, it's pretty much S stands for second law of thermodynamics, U stands for universe is expanding, R stands for radiation afterglow, G stands for great galaxy seeds, and E stands for Einstein's theories of relativity. Technically, Frank Turek has it slightly different, but even Stephen Meyer will point to that. It's his theories in general and his field equations that point to time, space, matter, and energy all having a singularity, a point of beginning, and then everything rapidly coming into existence, which, well, of course we know, or at least we believe that would have been God who essentially did that, right? That massive big bang, right? That massive explosion. We just say that, well, God was the one who banged the universe into existence. It requires massive amounts of energy, and I won't show in this, but fine-tuning and essentially to an astronomical number, which I would say requires a God, which is why I want to get into this, and I'll actually add that to my theory. I went over that. Yeah, what's contained in it is just shows that time, space, matter, and energy are limited and require a beginning, which is pointing to proof for the theory. But again, the theory itself is not perfect at all. It needs refinement. So the second law of thermodynamics, I remember this from school, and I absolutely loved it. It's the idea of entropy. It's actually a philosophical idea, but it's like a philosophical idea that is still also a physics. I don't want to say variable, but quantity. It has to do with the idea of like disorder. Kids are great at showing this off. If I were to, or say I was younger and living in my room, doing things, sleeping, playing, having Nerf gun fights, I create a mess, right? Randomness. Essentially, energy is being thrown in every direction, right? It takes energy for me to move my arm. And so if I move my arm in this direction, energy is moved to then this object, right? So that randomness is actually, in a sense, a loss of usable energy because it takes then more energy to reorganize. So it's like this. If the universe has a finite amount of energy, so like a limited amount, you only have this much energy, and then it takes this much energy to fix this mess you made. All right, you have to take a piece over here, okay? So you have this much left, and then you essentially create a little bit of a mess while fixing that mess. So then this over here is unusable. And so if you keep going in this direction, you eventually run out of usable energy. So the law of conservation of matter and energy states that matter cannot be created nor destroyed. So you don't actually have matter and energy actually coming in and out of existence randomly, right? It is something proposed by Fred Hoyle, but has been proven to be very, very wrong. It's just not possible. So that's why it's a law now. And the first law of thermodynamics shows, it kind of infers, let's see, where do I have it? It infers that the universe has a finite or limited amount of energy. So the laws themselves actually already gave this idea off. Like, scientists know this stuff intuitively. If you ask any physicist, they're just like, oh, this is like the most basic stuff you learn in high school. Because I learned it in high school. It's literally that simple, is that we have a limited amount of energy, and when it all began, it came into existence, but it's almost like it's a battery that's just running out of energy, and it just cannot recharge itself, right? So, just like you use an old clock where you wind it up, okay? It takes your own energy to do that. And then if someone's winding you, it takes energy to do that and something else winding that, right? It just, you essentially have to go back to a being that has unlimited energy to essentially start it all and to continue to sustain it. So even if the universe is, say, technically this has been proposed before, that's continually in a regress like this, where you have Big Bang, close, collapse, Big Bang, close and collapse, and then, and that's, of course, assuming a point of low entropy. But even with that, you still require a God to do that boom, 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 because of entropy. This is why the second law of thermodynamics points to a beginning, because of the amount of wear and tear away almost, the randomness, the disorder. And we know this biblically. The flower fades. Let's see, the grass withers and the flower fades, but your word, O Lord, will stand forever, right? We know that God himself is eternal, but the physical things wear down over time, right? We equate this with sin. I forget who, I think it was Stephen Meyer who actually pointed out the fact that entropy is very closely related to the idea of sin. This is why entropy is so philosophical. It's because when you get into the idea of sin, you're like, wait a second, these two mean the same thing. It's a wearing and tearing down of things and a disorder, a randomness, disorganization. So that's just one major point. I've heard someone say that it's only in a closed system. It doesn't apply to the universe, but it's actually, scientists will, it was actually on, I read this from NASA. They said this applies to the whole universe, not just a closed system, because the universe itself is a closed system. So the universe is essentially a closed system, and so because of that, that law applies. But that was just an objection I heard from an atheist. But the universe is expanding. This is actually a law now. It's called the Hubble and Lemaitre law, and this is really neat because this is what convinced Einstein to be a believer in God. And he originally had messed with his field equations a little bit to come out with a more like steady state theory where the universe is continuous and unchanging. Yeah, he messed with the cosmological constant. You're right. Yeah, he kind of tweaked it to where it's exactly the same as the hypothesized push and pull that is against gravity that keeps planets aligned. And so he says, oh, this cosmological constant is the exact same. So you don't have expansion, it's just all the exact same. Well, he messed with it himself. But this actually is what convinced him, and it was Lemaitre, who was a Catholic priest, who worked, he didn't work alongside Hubble. Him and Hubble, I think, were the ones who theorized and came up with the law. So it's someone else who actually worked with Hubble, but I'll read this here. This is from NASA. Astronomer Edwin Hubble confirmed that the universe was expanding in 1929 using observations made by his associate astronomer Milton Humason. Humason measured the redshift of spiral galaxies. So you all know that our sun is yellow, and that it's that color because of the temperature. It's actually let me explain this with a different point. The sky, we see the sky is blue because that's the color, the frequency that actually can reach our eyes in that amount of length. It's essentially the distance that creates that specific frequency that hits our eyes. So on different days, it'll be like a different color. Like as the sun moves around, like it will set red because the light is like bouncing off the earth and actually coming into the sky and bouncing back off. So it creates this like orange tint because it takes longer to come to you. So our eyes perceive it as red when it's sunset or violet in the morning, right? And so then we see it as blue in the day because that's just the length of the frequency that so happens to hit our eyes just right. It's absolutely beautiful how God created the world around us. And of course, I could even go into rainbows, but so galaxies really, 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 really far away, they don't appear as blue. Instead, they appear as red, which shows that not only are these being pushed away really, really far and going really, really fast because scientists can measure the frequency, the continuous frequency, and then measure the distance, or they can measure the velocity and the distance based off of the frequency. But then also galaxies that are closer are actually a brighter blue and purple color. So you see this like this line of a red shift, essentially, and almost like this cool rainbow color. And so this is what Humason discovered, is this red shift in galaxies that are really far away. And that just shows that there's some kind of almost like expansion, like everything is being like pushed apart. Humason measured in spiral galaxies. Hubble and Humason then studied Cepheid stars in those galaxies, using the stars to determine the distance of the galaxies, right? Which they compared the distances of these galaxies to their redshift and tracked how they are farther away. How the farther away an object is, the bigger its redshift. So it's more and more red the further away it gets. The pair that found objects like galaxies are moving away from Earth faster the farther away they are, at upwards of hundreds of thousands of miles per second. And so this is now Hubble's law, or Hubble-Lemaitre's law, which is literally, this is NASA here saying it, the universe, they confirmed, is really expanding. Now, if the universe, think about this, if the universe is infinite, like say it's continuous like Einstein originally thought, right? You know, it's essentially just the same all the time, which is what people have thought for thousands of years. They thought, oh, the universe is just eternal, right? It's just always existed. But if it's expanding, then that means that if you go back, it goes back to the single, boop, right? It goes to a single point where it starts, right? There's a beginning. That's the point of an expansion, right? I want to explain this like a cup, but I can't really explain it like a cup because plastic cups are like, they go out like this, but then they have that flat bottom. But yeah, essentially like a cone, right? It all has to come to one single point. And so you'll see later that this point is so high in density that essentially it gets to where you need nothing and then something and then infinity, and then everything comes out. It's kind of a very beautiful, graceful thing. It's called the singularity theorem, which Stephen Hawking and Roger Penrose came up, but I'll go further into this. So this is a really, really far away galaxy. This is the redshift. You see how these are all, like you have some far back here, those are yellow. This one's like kind of blue, violet, right? And really, really far back, you get a red galaxy. This is the redshift. This is what they had. I think this is actually the original picture. and they had zoomed in on it. So this one is the radiation afterglow, the R. I have to remember exactly what this is because my brain is fogged. Radiation afterglow. Ah, yes, this one was discovered by accident. This one was really cool because there were 3 scientists. I'll skip this part here. That's not too important. But there are 3 scientists who had proposed that if there was a massive explosion to the universe, right, if it really expanded from one point and everything just came out like instantaneously, there essentially has to be this like afterglow or like smoke, right? It's essentially like the smoke left over from the gun, okay, from the gun of the Big Bang. And it was Alpher and Herman went on to calculate the present temperature corresponding to this energy. They got the answer. It was 5 Kelvin. 5 Kelvin. So the color temperature of daylight is 5,600 Kelvin. So 5 Kelvin is very, 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 very low on the spectrum. It's extremely cold. It's faint, but it's still there. So it's essentially the lowest possible temperature, molecular motion, and thermal radiation come to a complete stop. Or that's absolute zero, sorry. But radiation energy at a temperature of 5 Kelvin is mostly in the frequency band of microwaves. So if you find radiation that's that temperature, it's actually in the range of microwaves. So, just so happened in 1964, Penzias and Wilson at the Bell Telephone Laboratories, and these guys were really cool because they actually were trying to create cleaner satellite communication. They were trying to kind of create like a higher quality radio, because when you turn on the radio, you kind of get some fuzz. You got to tune it a little bit. It's not like the cleanest thing in the world. So at this time, of course, radio is really popular, and also TVs are just really getting popular. And so they're trying to clean up this satellite communication and radio communication. They're trying to figure out how can we make this better. And so it says they began to investigate radio emissions. Yeah, they did. But not necessarily from the Milky Way. They had a really sensitive detector that connected to a large horn-shaped antenna, a previous use for satellite communication. When the 2 scientists tuned their equipment to the microwave proportion to the spectrum, they essentially tuned it to microwaves because they're like, okay, this is the frequency that radios are on and TVs are on, certain TVs, old TVs. And they found this really annoying background static that would not go away. They would point it in every direction. They would take it around on their fancy antenna. I forget exactly what it looked like, but it could spin around and point in different directions. And no matter where they took it, they even do it at different seasons, different times of the year, different times of the day, it would not go away. And they had no idea why until, well, actually, I think they had heard about this because I think it was Penzias who said, we're going to win a Nobel Prize. They did. They actually won a Nobel Prize because according to this hypothesis from these 3 scientists, Alpher and Herman, it was supposed to exist, but they never actually went out to find it. Well, these 2 guys found it on accident, and they, to equate the two, essentially, it is, in fact, around 5 Kelvin, and it is astatic in the world all around us that cannot be seen, only heard if you turn into microwaves, say on a radio. You get that part of that buzz, That's literally the smoke from the Big Bang. It's left over. It's very faint, but it's out there. And so this was just a pointer to a massive explosion. This was another point to it. But something that I have just a little detail here because there's actually a lot in this. But then lots of money. It was something like $200 million went into the satellite COBE. And then another, I think it was 50 million, or maybe it was 500 million, went into MWAP. It's a weird name. Satellites show these type of energy fluctuations when they actually go in. These satellites go into space, and they're like super sensitive. They have these massive cones. They're so sensitive that a watch would literally change the entire trajectory of its scanning. Like it would essentially create like this whole like beam across the picture. If it's like taking like a really sensitive picture of the universe, your watch would literally mess the whole thing up. It would just any like faint electrical frequency would just ruin the whole thing. So it was really sensitive to light and to the faint afterglow that the Big Bang had created. And honestly, these things all require like further study into these. There are books on these things, and a lot of this is just like history and science that you'll even find in textbooks. But I want to go further with this. But these energy fluctuations, which is shown in the radiation, it actually has to be to a very fine constant. I want to give you the number, and I will in a minute. But the number has to be like so finely perfect to have galaxies form. Like everything, it's almost like when you're at a pool table and you hit the white ball in to break everything. Imagine the chances of hitting all those balls into all the holes, all perfectly proportional, right? So the same amount of balls in each hole, which the chances of that are extremely low. But that's kind of a similar idea for what you need from this massive explosion, because all these atoms are going in every which way, every direction. So everything has to like bounce perfectly and hit and join and create molecular structures, and everything has to fit just perfectly to create like hexagons and octagons and even bigger structures and molecules. And then you need gases to form. You need these molecules to build upon each other. You need everything going in perfect successive order to have galaxies form. And so these satellites had actually read the energy fluctuations, which show it's like waves in the universe. It's waves in this radiation afterglow. And so those waves are absolutely perfect so that the galaxies can form. And it's, again, a ridiculous number. This is just, even at this point, I would say you absolutely need God. There's no way this could happen by accident. It's ridiculous. But I know you're pretty much all there. But I would say that people will ask you questions like, what do you know about this? What do you know about this? What do you know about this? What about this? What about this? And it takes research. It takes what I like to call loving the Lord your God with all your mind. You don't just love the Lord God with all your heart, with all your soul, which is great. But like, I've learned that my passion can only get me so far, because I will hit a roadblock where people will ask me questions and I can't even answer them for myself. Now, I've had a lot of doubts, but let me tell you, this research, which this is like 1% of the research that I've done. And that's not to brag, that's just because there's so much, I can't even contain it. It's book length, it's crazy. And there are books and books and books, okay? But study to show yourselves approved unto God, workmen that needeth not to be ashamed, but rightly dividing the word of truth. And if you want to understand God's word, also understand the world around you that God has created. I mean, so I'm just saying that if your head's getting a little overloaded here. But black holes are another pointer. It was Hawking, and it wasn't Hawking actually, and Penrose. It was someone else before them, but they were the one who kind of coined the idea that black holes that are essentially the center of galaxies, they are singularities of these extremely high densities. They essentially have matter that's so perfectly packed and stacked that massive amounts of energy is created, that if something is like sucked in, it's instantly crushed and separated. So if you were to be pulled into, say, like a supermassive black hole, all of your atoms would be torn apart and essentially just put into this like this perfect sphere, right? It would just all be put into there, which is immensely tiny. And so But supermassive black holes are ridiculously huge. But to get that big, they have to absorb matter and energy. They have to absorb this over time. It takes a long time. It's not just some instantaneous thing, which by God's grace, we have not been absorbed by a black hole yet. But the universe will collapse technically before that happens. And before the universe collapses, Jesus will come. And he'll create a new heaven and new earth, for goodness sake. So we have that promise. But this is the largest known black hole. It's S50014 plus 81. I don't know why that's a name. This is our solar system. Do you see that? Do you see this tiny dot? That's our solar system. This is the black hole. Okay, a black hole is the center of a galaxy, right? Woof. That's huge. The mass equals 40 billion suns. So imagine 40 billion suns. I can't imagine that. The diameter equals 37 times the size of Pluto's orbit, which is massive. I'm not going to talk about, well, its lifespan, it says 1.3 times 10 to the 99th years, because until it dies out. But they essentially say the universe is going to collapse before this thing dies. It just will get so big to where other galaxies are so far away it can't absorb energy, and then eventually it just dies out. But here, first you have nebula, which is essentially just gas and clouds. And when you have gas collide with heat, of course, you have an explosion. But when this gas actually, it almost like wraps itself around due to gravity. It's kind of like shoved forward in a direction, and then like other atoms, like other matter is involved and in this energy, and like putting it just the right spot, and gravity kind of compacts it all in this like perfect circle, and it creates a main sequence, which is our sun. It's actually super, super, super young. After that, it gets really big. After absorbing other planets and other gas, it turns into a red giant. Then it turns into a type of like planetary nebula where it kind of slowly starts to blow, and then it creates a white dwarf. So you kind of have this cycle. But to get a black hole, you have a high mass star. Actually, our star is a medium mass star, but you have blue suns out there, which are also young and very hot. Then you have a red supergiant. Then you have a supernova. These things essentially, they don't just like spread apart and just break apart. They actually implode, create this giant explosion. You probably all have seen the idea of like a supernova. It's huge. It's just like a mini Big Bang. Very, very powerful. It creates a neutron star, which is very high mass, and then it creates also a black hole. So after a supernova, it creates a neutron star and then a black hole separate from it. Usually that black hole just absorbs the neutron star and then gets more powerful. But these things start like really tiny. Like, I mean really tiny. And they get big and big and big, which takes a lot of time and a lot of energy and matter. And so this just points that if you take the clock all the way back, the universe had to start with humble beginnings. It had to start. And this goes into the next part. Beautiful black hole right there. Isn't that gorgeous? These are. This galaxy is 2 times the size of ours. Very cool. Wrong one. This is where Stephen Hawking and Penrose came in. I think you all know who Stephen Hawking is. Maybe you don't. He is known as he has the highest amount of accolades in science history, and especially in quantum physics and astrophysics. He is known as one of the most intelligent scientists in this world. Some people consider him more intelligent than Einstein. He did pass away in, I believe it was 2018. Not a believer in God, very sad, but he also had terrible philosophy. That was one of his issues. But he was an amazing scientist, and actually he gave a lot of people a lot of reason to believe that God created the universe. Such as him and Penrose came up with a theorem which is called the singularity theorem, or singularity theorems, which invoke the idea of the universe being wound backwards like a clock. and everything expanded from a single point. So imagine the universe going back in time. This is why I kept showing this with my hands. They came up with this. It goes all the way back, and everything collides onto itself. Physics itself actually breaks down in this singularity. Nothing's bound by any other laws because everything's so compactly tight that nothing's essentially going to happen. So then if you actually continue to go back in time, this is where the idea that nothing, I think it was Hawking. Yeah, Hawking said nothing created everything. Maybe it was Penrose. I'm sorry I'm getting these guys wrong because I didn't write this down clearly. But there was a scientist who said, oh, well, nothing created everything, right? Because you need an infinity. To have an infinity, you need a zero. You need a zero and then infinity, and then I can't explain that in full detail. I remember Stephen Meyer talking about it. But this is the modern consensus of scientists. The universe began from nothing. They don't know why. They just know that there's nothing, and then there's something, and then the universe, right? That's what they've observed. And so many people, many scientists who are especially more philosophically biased will say, okay, well, Stephen Hawking wrote a book about how gravity is essentially the cause for the universe. But that's ridiculous because if energy had a beginning, then that means that it couldn't have started at all, right? If it can't be in nothing, right? You essentially need something greater than all physical, material, everything related to space and time. So that's where the God theory comes in, that I have essentially posed and I want to further refine. But even many apologists have come up with this, like a timeless, spaceless, immaterial, all-powerful, all-knowing, because he would have to be high in knowledge to create a universe like we have. Personal, by the definition, because in order to create something, you need to be personal to a point. So you need, in a sense, this like personhood. So this has all been posed philosophically with the science that we have. Okay, if there's a beginning, you essentially need something that is greater than what began to have then began at all. So this is the cosmological argument. This is only one tiny, and I mean a tiny piece. I didn't even go over all the details. But only one tiny piece of how God's existence is necessary for the universe to exist in the way that it does and continue to be sustained. And the continued sustaining I will show in this absolutely lovely, oh, that's not it. The absolutely lovely number, here it is. I can't even explain this number. This is how big this number is, okay? This is just the low state of entropy. So I talked about entropy earlier, how it's about like the amount of randomness you have, but it's a quantity. So it's actually measured in whenever you have some kind of like energy transfer or heat transfer. That's what thermodynamics is about. It's really about heat transferring and energy transferring. An amount of entropy is created every time. So you need like in the universe, a low enough state, not necessarily zero, but it has to be low enough that the universe can actually start and continue to work, like actually work. Like it has enough energy to run, you know, just like a battery. It has, the way that even batteries work is their energy isn't lost, it's just moved. So that's why when you recharge it, it just replaces it back so that it can be used again. But as a battery wears out, as you recharge it, what does it do? It slowly dies, and then it becomes less useful, right? That's entropy at work, right? So you need a low enough amount of entropy, just low enough so everything can start just perfectly. Okay, so the low entropy state needs to be 1 in 10 to 10 to the 10th power of 123rd power. So imagine 1 or 0.0 with 1,023 zeros behind it and then a 1. So you need it to be that low of a state, that little amount of entropy. That's a lot of zeros. I can't even. That low of a state of entropy in order to have everything just start right. That doesn't even have to do with that's not even the cosmological constant, which is also really high, which is the difference between gravity from large masses pulling and the hypothesized push and pull that pushes back, that keeps planets in their orbit. Yes?
Can I ask, or is that interrupted?
No, it's okay.
So
I'm almost
the
done. So.
law of entropy then is basically that things are degrading, that because energy gets used up.
Yeah,
That things are degrading. So there was a point where mass, matter, energy, time, and space were so packed. That was all the energy that was ever going to be created. That point.
yes.
And as it expands, it continues to expand. It's sucking. What's the word? It's using.
Yeah,
Time,
it's
space, energy, mass. So
Yes.
it's expanding, so it's using more and more and more and more.
Yeah,
to
exactly.
A point where it's all used up.
Mhm.
When it's all used up, basically these black holes are the engine that will take the universe and collapse it when everything collapses.
Yeah, I think
Is that right?
you got it pretty close. The black holes aren't necessarily driving everything down. It's just
What
that
you got, the
black.
thing that would,
What's driving everything down is
you don't have to. I mean, I'm just trying.
No,
to
no, that's okay.
I'm understanding this, right?
yeah, either it's proposed that either the universe is going to collapse in on itself or continue to spread apart. Like your atoms will literally rip from themselves.
But it's the law that.
But you explained it pretty well. Like
The
I
law-
hope everyone heard her because she.
No, I'm just trying to understand this.
No, I know it's very.
And so
It took me a long time.
that when everything is basically, energy will be used.
Yeah,
As we
exactly.
use it.
Right, because like the sun is continually burning its gas. It'll eventually run out of energy.
So
Right.
then
The same
that-
with the Earth. It has a core that has a certain amount of gas in it. If it burns it all out, it's just like an engine, uses up all the gas.
You need to refill.
Yeah, exactly. You need a refill. But
So-
you can't create new energy unless you have a being that can break that law.
And it was already created at one
Yeah,
point.
it was all created at one
Everything
point.
that was to be created.
Yes.
Was at that one point.
Mhm.
So then the theory of evolution that says that creation is building up, that one species will mix with another species and will create even another species. In other words, creation is building up. That's actually opposite
Yeah, it's
to this, and therefore
Yes.
false.
Yeah, it actually does break the law of entropy.
It
That's
does break
one.
the law of entropy.
Yeah, that's one physical or physics issue with evolution. Is it breaks
it's
the law?
false.
Yeah, it breaks the law of entropy.
So entropy
Um,
is a constant. It's
Yeah, you're right. It's
Okay, so
it-
I have a headache, but I think.
yeah. Well, I hope I didn't like overload people. I know I'm like.
I had a headache when I got here.
But if any of you have questions, now's the time to do it. I went over, but I also want people to ask questions.
Okay.
Yeah.
It has something to do with body of chaos. I mean, you say, everything, supposedly everything fell into place by itself, but things don't normally fall into place by themselves. You can't just take a bunch of wheels and gears by yourself.
Yeah.
Pull it up and pull it down and fix a watch.
No, you're exactly right. I mean, there are of course mathematical chances that that will happen, but that's why
Very slim.
yeah, that's why even just the low state of entropy I gave you, and even the cosmological constant, it shows you that it's really, really improbable that this happened by accident. It shows that it's really, really, really probable that something outside of the universe kind of, as Fred Hoyle said it, monkeyed with physics. And Fred Hoyle, excuse me, was an atheist who became a theist. He was into the universe being eternal. And he knew that, okay, if the universe had a beginning, there has to be some kind of God. And he did work on that into now part of the fine-tuning arguments. And he became a theist. He's just like, there's some kind of super being that monkeyed with physics. That's how he put it in his book. And it's just hilarious because it's like, well, yeah, the Christians were right.
Well, you know how God restates things over and over?
Uh-huh.
He's always telling a story that kind of restates this story, or they all confirm each other. So then in the
Yes, yeah.
explosion
The
of-
Cambrian explosion, right?
Yeah, of beings that says that, the way in Genesis, when it says God created this one day, literally, it wasn't 3,000 years
Mhm.
one day, it was one day, one day, one day. And one day there was everything. So that's kind of like this, that there was something and then all of a sudden everything.
Yeah, ex nihilo, right?
Huh?
Ex nihilo, it means from nothing.
I don't know that.
I believe it's Latin. It's probably Greek.
But I mean, there's an analogy, it seems like there's an analogy there, God's
Yeah,
restating-
exactly.
Restating.
Yeah, in the beginning, God created, right? That's the Big Bang theory.
The Big Bang theory.
Hugh Ross actually became a Christian off of that,
Yeah.
too. So, yeah.
And that's the idea, supposedly there's supposed to be a machine that's turning out universe after universe. But
Yeah.
if they do that, who built the machine?
Yeah, I've heard that before. The multi-universe theory. It's string theory that there's like a universe machine that just builds millions of universes, and just the one that we're in is the one that came out just perfect to have life. So it created like an immense number to where we just got the right one, which is utterly preposterous if you actually think about it. But
Who built the machine?
yeah, who built that machine, right? You still need some being outside of that realm, like completely independent, to have then created that machine, for that machine to then create all those universes, to then create that perfect universe so that we can exist. So we still need God,
So
either way.
When this person that says multiple universes, that's where this alternative,
Yeah.
what is that, alternative
Fourth
universes
multiverse.
existing and we go in.
Yeah, it's
That's all-
multiverse.
that's all
Multiverse.
false,
Yes, Anna?
right?
Um,
Okay, that's
I was gonna say, I think it can be a little difficult.
It's theoretical.
Sometimes, because based on
Well,
the theory of the singularity point.
Singularity theorem, right?
And based on the expansion as well, I think sometimes we as Christians can kind of just assume that when the verse says, "In the beginning God created the heavens and the earth," we can just think, like we just think pop, like
Yeah,
it's
boom.
just there, right? Rather than a process.
Yeah.
And I think that's been an issue in a lot of Christian theory because evolution was such a big thing. And
Oh,
because
yes.
it was so against, and it really is, evolution itself is against the Bible because it's saying that we went from nothing to a better man, which isn't true at all because we're going down. But,
Yeah.
but I think it's really the thought that, like, God didn't use a process, and when you really look at the universe, God tends to use more processes for things. Like, I think of even how rain works.
Yeah,
It-
right.
it really is like kind of like a winding, especially if things are dying down.
Yeah.
I feel like he would have, like, it's possible he would have, even when he made Adam, he didn't just poof Adam.
Yeah, he took time into designing him.
Exactly.
Yeah, because that's the idea of like why God's personal, why he's a personal creator, because he took time and thought into creating the universe around us. That's what the fine-tuning argument shows. And I know you're right. A lot of Christians have been scared of the Big Bang, but like, don't be scared of it at all. It gives so much pointing to the Bible. So many people have become Christians and theists off of the Big Bang. It's crazy. Yes, brother?
Well, yeah, you say Big Bang, big creation is what it was.
Yeah.
The way you explain things all coming back to one tiny thing, that
Mhm.
would take billions of years, for them to expand. But when God created them, they were already in that time state when he created them, not billions of years before, because he did it all during this first 6 days.
Yeah.
Seventh day rest.
Yeah, the time, I have an issue with the time. Even Hugh Ross will point this out because he does a lot of work on the fine-tuning argument, and he's written a lot of books. But the age of the universe is still in debate. It could be 13.8, it could be 14.6 billion years old, it could be 15.6 billion years old, it could also be 16 billion years old, but it doesn't really matter
Be 6,000.
because God, yeah, it could be 6,000, right? God could have just, yeah, God could have like he created Adam fully grown. He created the universe fully grown to where then you can have life on Earth because there's been a lot of study into that. You go back like something like 100,000 years technically. I'm not saying that that's actually true, but 100,000 years in the universe's life, you couldn't have Earth exist or life exists on Earth. So there's times when you look at like this history of the universe that has been gone over. It's just like God's hand is in it and getting Earth to the very perfect spot. We're actually on the outside of our galaxy, which is Earth was originally right next to the black hole. It was actually blasted just perfectly, pushed out of the way by a supernova that could have destroyed it, but essentially it collided with the black hole and made the black hole significantly larger, but pushed us just out of the way, and now we're on the outside of the galaxy. Now we can have life, and there's actually even radiation that comes from different galaxies. Not only can we see them, but we also miss the harmful stuff. It's like so insane, the perfection that we have, or like, I think you all know this, right? The tilt of our Earth is so perfect that if it was any different, we would either freeze or burn to death, or like the fact that we're so perfectly aligned with the sun. If we were any closer, we'd burn. If we were any further away, we'd freeze. It's just, you see like God's hand, like he monkeys with physics so that we can exist. So. Yeah, and it's possible, but it's never been. It's only theoretical. Just like the multiverse, there's literally no evidence for it at all. It's just theoretical.
I think you gotta be careful saying God
Oh,
monkey,
well, it was just a joke from Fred Hoyle.
Imperfection.
Oh yeah.
Because you say monkey, he's trying until he gets it right. No, God got it right all.
Oh yes. No, and I agree. It's just an expression. Yes.
I'm very true to the idea that when the Big Bang happened on, of course things were moving faster than daylight too. So, and of course,
Yes.
with time, we only have time because we're within the universe too. Obviously, I mean, God's timeless.
Yes.
And so obviously, from our perspective, and his perspective, things are not.
Yeah. From our perspective, it looks like a long time, but it could easily be 6,000 years, right?
Or it could be.
Yeah. I don't know.
We don't know what the actual scale is for time for passing.
Yeah. Personally, I don't care about the age of the universe. I just have a neutral stance, just to put that out there. But yeah, you're right. Yes.
So we can't figure out that.
Yeah, exactly. It's next to impossible to figure out. You have to ask God. And he's like, you believe the universe was old? Oh, you're going to hell. He's never going to say that. He's going to ask you, did you put your trust in my son? Not, how old do you think the earth is? Was that it? Okay. All right. Thank you all so much. I hope, again, I didn't overload your heads,
Can I
but
just ask one more question?
yeah.
So this kind of disproves that multi-universe theory.
Well, the multi-universe is disproved usually by the fine-tuning argument, because this is just the cosmological. This is that the universe had a beginning. But the multiverse is like a whole different issue, and again, the multiverse has no actual evidence for it.
Is
So
that where they get this, there's parallel universes?
yes, and parallel dimensions and all that.
So that's false then?
It's
Or we
not
don't know.
true. It's not true that we know of. You know, it's kind of one of those things you need to prove it. You know,
There's no way you can go from this universe to another one to prove what.
yeah, unless you want to go through a black hole. I mean.